Hi, I'm Lena Kaval, and this is my DataViz project titled Exploring the Solar System. As you can see here, I have many different visualizations, and I tried to keep it in a very simple layout that would be easy for my users to understand and go through the data. So, um, the first five are my bar charts. Um, Hovering over it enables you to view the tooltips, um, as well as clicking to filter the other charts. This one's my histogram, and I made bins of 20 instead of 70 or whatever. That was the default value that was in our examples. And this similarly can also be clicked on to filter the other items, as seen there. This one's my my line chart, and hovering over shows you the year, the exact year, and the exact count of the discovery of exoplanets, so that you don't have to try to guess that this is 2005 and that's 40. Here is my scatter plot. As you can see, I have radius and mass. I decided to remove the text completely because I had to log scale my scatter plot, and I figured that having it log scaled would mean that users would not really be able to understand, 1, 10, 100 if I showed the text. So simply, users can compare different planets against each other. And I think that's why it's very important to have like Earth and Mars and Mercury as reference points. Because if you go this way, the radius is bigger than Earth. Go this way, it's smaller. Similarly, if you go above this, then you know that these are all have more mass than Earth. So that's my scatter plot, and as you can see, there's also tooltips. My last visualization on here is the data table. So as you can see, we can scroll through and view all the entries that are in my data. And I'm using a library called Tabulator to create this so that it was much easier to format. And it automatically has these sorts, which was really convenient. It's simple. The decision I made here is that these are all more qualitative data instead of quantitative data, as you can see in the other charts, because you can't really visualize facilities. I mean, you could, I guess, make a map, but that's not quite what I was hoping to do here. So this is my data table. If you click on a row in your data table, you're able to see more information about that specific exoplanet in my system browser. This is what it looks like right now. It's not quite what I wanted it to be, but some highlights here are that the sun has different colors based on the spectral type, so AFGKM, based on a source I found. Planet type is also different based on the type of planet it is. This one just uses a simple scale that does not have anything to do with the value of the planet. So simply clicking off that like that gets rid of the pop-up, or clicking on the X also gets rid of the pop-up. Similarly, I can click on any data point in my scatter plot and also pop up this window. So that's all for my visualizations. I did want to show this one thing that I also decided to add is this checkbox here, click to include data with missing fields. What I noticed is that if I filtered all my data based on like if it was missing one field, then I wouldn't have much data to work with total. As you can see, this is only 1,500 plus 400, so about total 1,600 data points, while our actual data has about 7,000. But I figured that if I'm going to be showing linked bar charts and all that, it would be better to make sure that I use the exact same data. So I didn't want to just filter, undefined stars for this one and undefined habitable places for that one. So enabling this will show you all the data. And making sure that it's not the default value means that the user has to specifically want to see this data, and they know that it's possible that they may make discoveries that are not valid. This isn't what I mean to show them, but I want to give them the ability to see this. This is interesting because, as you can see, radial velocity actually is the second most popular discovery method after transit once you include all the data, even if it has some missing fields, the most popular missing field being radius and mass, as you can see here. But that's about it for my visualization. Thanks for listening.